Well, thank you so much. So now we will start with definite integration. All right. With respect to JEE point of view, it's highly important chapter. And two more chapters are dependent on it. Definite ho gaya, area is there. Then indefinite we have already covered. And I try to do so many questions as much as I could. And then there we go with the differential equation will be there. So a lot of things will be connected all together. So, and I also assume, okay, just let me know how many of you have already done definite integration in your schools. Please raise your hand or thumbs up. Show your thumbs up. If you have done definite integration in your school, please let me know. Thank you, Bishan. How about the others? Okay, so others, you guys have not started it in your school or you have not completed it. Priyanka? Priyanka, am I audible to you? Yeah. Please respond in the chat box. Have you already completed definite in your school? Very good, very good. Bhagat? Suraj? Either show a thumbs up or just let me know if you have done it or you did not do it. See, rest of you, I think, are not too much interested in talking. Chalo. Now we'll start with definite integration. See, one very basic property is, let phi x be the antiderivative of the function fx defined on a to b, and d by dx of phi x is fx. All right. Then definite integration of fx over a to b is denoted by this. This is it. And see, and how do we define it? It is like integration a to b fx dx. See, we are already aware of that integration of fx dx will be phi x plus constant. If I go with the indefinite integration, then integration of fx dx will be phi x plus constant. So this will be what? Phi x plus constant, and limit will be a to b. This b is what we call upper limit. And this a is what we call lower limit. Got it? So it will be what? Put the upper limit phi b minus put the lower limit phi a. Am I clear? So this is the basic concept behind definite integration. Got it? Now, if a simple question I ask you, very simple question, integration minus 1 to 1, integration minus 1 to 1, let's change the limits. Integration 3 to 8 sine of under root x plus 1 upon under root of x plus 1 dx. Yes, how do we do it? Now see, first of all, nothing much to do. We will simply do indefinite integration. To do indefinite integration, you will make a substitution under root of x plus 1 as t. So 1 upon 2 under root of x plus 1 into dx is dt. So that means dx upon under root of x plus 1 is 2 dt. Am I correct? So it will be sine t, and dx upon under root of x plus 1 will be 2 dt. Now see, these are the limits of x. Now you have changed x in terms of t. So new limits will come that will be in terms of t. Now if I take x as 3, your t will be 2. If I take x as 8, your t will be 3. So limits of integration will convert from 2 to 3. Got it? This is how we handle in case of substitution. Now 2 came outside. Integration of sine t is minus cos t and limit will be 2 to 3. So that is 2 times minus cos 3 plus cos 2. So upper limit minus lower limit. Got it? So the answer will be twice of cos 2 minus cos 3. Got it? Now let's do another question. I is integration 0 to 1 x ln 1 plus 2x dx. Options I give you. A option is 3 ln 3 upon 8. B is 3 ln 3 by 4. C is ln 3 by 8. And D is 2 ln 2 upon 5. Give it a try. Then we will start with a poll. Now I'm starting with a poll. Just let me know your correct answers. Yes. All right. Have you guys done it? Sure. Now let's do it. See, the question is this. 0 to 1 x ln 1 plus 2x. The question is of integration by parts. That's pretty much clear. So I assume it as my first function and this one as my second function. So it will be first. Integration of second is x square by 2 minus integration 0 to 1. Derivative of first. Derivative of first will be 1 upon 1 plus 2x multiplied by 2. Integration of second, that is x square by 2 dx. Am I correct? Now, if you put upper limit, you get 1 by 2 ln 3. Lower limit, it will be 0. Minus 0 to 1, it is x square upon 1 plus 2x. Now let's do one thing. Multiply it by 4, divide by 4, then subtract 1, add 1. Correct? So this will be what? 1 by 2 ln 3 minus 1/4 of. Now see, 0 to 1 में 4x square minus 1. It will be 2x minus 1, 2x plus 1. Now if I split the denominator, one term will be 2x minus 1 plus 1 upon 1 plus 2x dx. Got it? So it will be ln 3 upon 2 minus. Now integration 2x is x square minus x plus ln of 1 plus 2x upon 2. Limit is from 0 to 1. So now it's done. Ln 3 by 2 minus. If you put 1, you will get 0, 0, ln 3 by 2. Ln 3 by 2, and outside also there is 1 by 4. So 1 by 4 is here. And minus at 0, everything is 0. So it will be 3 ln 3 upon 8. Got it? This will be your answer. Have a look at it. I did nothing new. Simple indefinite integration it is, then just put the limits. Got it? Now, in general, a to b fx dx, this is an important point. In general, a to b fx dx represents the algebraic sum of the area of the region bounded by the curve y equals to fx, x-axis, and the ordinates x equals to a, x equals to b, as shown in the diagram. All right. So like this is the diagram. So this is your curve y equals to fx. So a to b mein, this is x equals to a. This is x equals to b. So a to b integration fx dx. This is the algebraic area. So this algebraic area word is important. Algebraic area means this is the area which is considered with sign. Means if it is above the x-axis, it will be positive. If it is below the x-axis, it will be negative. Getting my point? If you are taking it from A to B, it will be positive. If you are taking it from B to A, it will be negative. So this is what algebraic area is. In the next chapter, when we will do application of integration, where there will be area we will be calculating. So in that case, that will be numerical value of area. So that won't be algebraic area. Even if that would be negative, that would be considered positive. Got it? Write down a simple question on it, since I told you it's an algebraic area. The question is, integration 0 to 1 e to the power x into ax square plus bx plus c dx is 0. What does it mean? What does it mean? Now see, in A to B, if you realize e to the power x is always positive. Now, if this combined area is getting 0, that means that ax square plus bx plus c kind of the function here, it is sometimes below x-axis, sometimes above x-axis. only then this combined area can be 0. So this quadratic graph of this quadratic between 0 to 1 can be like this. Because if we calculate the algebraic area, we get this particular area as positive, this one as positive, and this one as negative. And with multiplication of e की power x, this entire area goes 0. Another possibility is the graph can be between 0 to 1. It can be like this. So that this goes positive, this goes negative. With respect to multiplication with e की power x, which is a positive function, this entire area goes 0. So that means what? That means this quadratic ax square plus bx plus c has at least one root in 0 to 1. That means this ax square plus bx plus c equals to 0 has at least one root in 0 to 1. Now we cannot exactly say if there is one root or there are couple of roots, but yes, there are roots. Only then we can make this definite integration 0. Got it? Now, evaluation of definite integration by substitution. This is what I already covered. And I'll take another example on it. Say, the question is, I is equals to integration 0 to pi by 4 cos 2x under root 4 minus sin 2x dx. 0 to pi by 4 cos 2x under root of 4 minus sin 2x dx. Got it? Now its answer is, if it is p minus q under root q upon q, then find p plus q, where p, q both are positive integers. Yes. Get the answer and give me your answer in the chat box. This is a numerical answer type question. Yes. Yes, everyone quickly try. Yes. Now see, this is easy. There is a function sin 2x whose derivative is written over there cos 2x. All right. So a substitution I do, I take 4 minus sin 2x as t square. 4 minus sin 2x as t square. So it will be minus 2 cos 2x dx will be 2t dt. So cos 2x dx is minus of t dt. So that is, now see the limits. If I put x as 0, t will be 2. If I put x as pi by 4, t will be 4 minus 1, 3, t will be root 2. Cos 2x dx will be minus of t dt, and under root of 4 minus sin 2x will be t. So it became t square dt. So answer will be t cube upon 3 with a negative sign and limit 2 to under root 3. Now if you put the upper limit, it will be 3 root 3 minus, if I put the lower limit, it will be 8 upon 3. So your answer is 8 minus 3 root 3 upon 3. 8 minus 3 root 3 upon 3. If I compare, this P is equals to 8, this Q equals to 3, and this P plus Q equals to 11. Am I clear? Now, let's go with the properties of definite integration, which most of the properties you have already covered. We will do certain examples, good examples on it. So the first property is alpha to alpha fx dx will be 0. Definitely, if upper limit and lower limit are same, the value of this definite integration will go 0. Got it? Second property, alpha to beta fx dx will be alpha to beta ft dt. Because here the parameter, see, this variable x or t does not matter, because ultimately you are going to get answer in terms of alpha and beta only. Am I clear? Then alpha to beta fx dx is also minus of beta to alpha fx dx. That means if I interchange the upper limit and lower limit, the value of the integration changes in sign. If I interchange the upper limit and lower limit, the value of the integration changes in sign only. Got it? Now, alpha to beta fx dx is like this. We can break the integration at as many number of constants as possible between alpha and beta. So that means a to b fx dx will be alpha to c1 fx dx, c1 to c2 f of dx, c2 to c3 fx dx, and so on, cn to beta fx dx. Okay. Now this statement is not correct. Definitely we will consider c1 c2 in between alpha and beta. Why would I consider outside alpha beta? Getting my point? But yes, if required, C1 and C2 can be outside alpha and beta also. That does not make any difference over this property. So the C1, C2, C3, Cn, they can be between alpha and beta. They can be outside alpha and beta. Got it? Now, alpha to beta fx dx is, see, this is very important property. A lot of question you see from this property only. Got it? So alpha to beta fx dx is alpha to beta f of alpha plus beta minus x. This x has been replaced by sum of limits minus x. And the value of integration does not happen. This is a short form of the same thing. 0 to alpha fx dx is 0 to alpha f of alpha minus x dx. Got it? Then minus alpha to alpha fx dx will be, so rest of the properties we'll do in a while. First of all, let's try few questions over these properties up to property 5, which is in NCERT property 4. So the first question is I equals to integration 0 to pi under root of 1 plus cos 2x upon 2 dx. Yes, right. 0 to pi under root of 1 plus cos 2x upon 2. Options are A1, B2, C3, D4. Quickly solve it, then I will start the poll in a moment. Yes, quickly try. Now, if you have done it, mark your answer in this poll section. Yes, others, please participate. Now, we got a variety of answers, but those who have marked 2, I think, are correct. See, this will be integration 0 to pi. 1 plus cos 2x formula is 2 cos square x. So it will be under root of 2 cos square x by 2 dx. So this 2 will cancel. This is 0 to pi under root of cos square x dx. So that is 0 to pi mod cos x dx. Now there I go with the property 4. Got it? So what it is? 0 to pi by 2. Now this mod cos x will be in first quadrant. Cos will be positive. It will be cos x only. And in pi by 2 to pi, it will be minus cos x because in second quadrant cos is negative. So its modulus will be positive. Am I correct? Fine. So if you just place do the integration, cos x integration is sin x, limit 0 to pi by 2, and minus cos x will be minus sin x, limit will be pi by 2 to pi. Answer you will get 2. Got it? Simple question it is. Now, see a next question. Question is integration 1 to 4 greatest integer of x square dx. This is greatest integer function. 1 to 4 greatest integer of x square dx. Now this 4 is going to be too much. Let's do it 1 to 2 is for sufficient. Let's do it 1 to 2. Now see, they are saying 1 to 2 greatest integer of x square. See, if your x lies between 1 to 2, so your x square will lie from 1 to 4. So in between 1 to 4, x square will be integer while x square will be 2 and then while x square will be 3. So that means between 1 to under root 2, it is greatest integer of x square dx. Then under root 2 to under root 3, again it is greatest integer of x square dx. And then under root 3 to 2, again it is greatest integer of x square dx. Correct? Now, if x lies between 1 to root 2, x square will lie between 1 to 2. X square 1 to 2, the greatest integer will be 1. Correct? Now, if x lies between root 2 to root 3, x square will lie between 2 to 3. So, x square between 2 to 3, its greatest integer will be 2 dx. And then root 3 to 2, if x lies between root 3 to 2, x square will lie between 3 to 4. So, x square lying between 3 to 4 means it will be 3 dx. So, it is root 2 minus 1 plus twice of root 3 minus root 2 plus thrice of 2 minus root 3. Okay. Now you just manage with this calculation. You will get your correct answer. Am I got correct? Have a look. Now, let's see another question. I is integration 0 to pi dx upon 1 plus 2 to the power 10x. Yes. Give it a try. Options are A pi by 4, B pi by 2, C 0, D pi. Quickly try it. And once you try, then mark your answers in this poll section. Yes, be quick. Very good. I got one answer. I got one response. Others, please also try. Now see, I will apply that property. Property was that integration 0 to a fx dx is integration 0 to a f of a minus x dx. So you replace a by means you replace x by pi minus x. So this is 0 to pi dx upon 1 plus 2 to the power 10 pi minus x. Am I correct? So it is 0 to pi dx upon 1 plus. It will be 2 to the power minus 10x. And if I take LCM here, it will become 0 to pi 2 to the power 10x goes upside upon 1 plus 2 to the power 10x. Correct? Now add this I and add this I. So you will get 2I as integration 0 to pi 2 to the power 10x plus 1 upon 2 to the power 10x plus 1 will cancel out. This answer is pi. So implies your I is pi by 2. Got it? Now, check another question. I is integration 0 to pi by 2 dx upon 1 plus sin x. Yes, what to do? Give it a try quickly. Yes, quickly try. See what I can do. Replace, first of all, apply the property 5. Replace x by pi by 2 minus x. So it will be what? 0 to pi by 2 dx upon 1 plus cos x. Now see that addition subtraction cannot be done, but I know it can be written as 0 to pi by 2 dx upon 1 plus cos x is 2 cos square x by 2. And now it has become very easy to handle. Got it? So it will be 0 to pi by 2. Half came outside. Cos square x by 2 goes upside secant square x by 2 dx. Its integration is tan x by 2 upon 1 by 2 limit 0 to pi by 2. 1 by 2 cancel. It will be tan pi by 4 which is 1. So your answer is 1. Got it? Am I clear? Now, one more question we'll do. Very, very good question. Very important also. I is integration 0 to pi by 4 ln of 1 plus tan x dx. Its result is something like you can also remember it. So A option is pi by 4 ln 2. B option pi by 8 ln 2. C option pi square by 4 ln 2. And D option pi by 2. Yes, quickly try it. Poll is waiting for your response. So mark your answers into the poll. Yes, please give it a try. Yes, two students responded, both responded in favor of option B. Others, please also respond. All right. That's good. Now let's see. First of all, apply the same property. Replace x by pi by 4 minus x. So you get 0 to pi by 4 ln of 1 plus tan pi by 4 minus x dx. So that is 0 to pi by 4 ln of 1 plus. Now tan pi by 4 minus tan x will be 1 minus tan x upon 1 plus tan x dx. Now if you take LCM, it will be ln of 2 upon 1 plus tan x dx. So it is 0 to pi by 4 ln 2 dx minus 0 to pi by 4 ln of 1 plus tan x dx. Now see, this is same where we have started I. So take it to the left side. 2I will be pi by 4 ln 2. So your I will be pi by 8 ln 2. Am I clear? So just have a look. Very good question it is. Got it? So that would be all for the day. In our next class, we will start with property of even odd functions, like definite integration of even odd functions, and also do property of 0 to 2a fx dx. Got it? So in the meantime, just I'm launching a class feedback poll for you. So